Hi, I'm Jake, and on behalf of Team 19 of Max, Hamdan, and Noah, I'll be introducing our group's project. So we focused on generative adversarial networks, and our group's major changes from 48 to 49 was to pivot away from the differential between classical computing and quantum computing and how a generative adversarial network can work in either of those two environments. We did focus on just getting a classical computing GAN to operate, and we were successful in doing so. Um, Hamdan will go over the classifications and results of that. Noah will go over the actual results of our experiment, and then Max will present future work in this project if necessary. During our demo day, we did successfully demonstrate what a GAN is, and we had a GUI to show our visitors just how it works and how each segment of our training impacted accuracy and the results in general. I'll now pass it on to Hamdan, and he'll go over the classification network. Thanks.
Thanks for that, Jake. So our GAN is actually a unique type of GAN called a conditional GAN, in that we can choose the output of the GAN from our three different classes that we have. We have humans, drones, and cars in our original data set. So we can prompt the GAN to create samples specific to these classes. And going forward to kind of test the efficacy of our GAN, we trained a classification network on the full set of our original real data, so non-synthetic. Then we took 20% of that and added 80% synthetic and went on to do 40, 60, 80, another 100. And we use this to kind of benchmark the effect of our synthetic data on a classification network. And I'll be passing it on to Noah to talk more about the results of this experiment and what we can conclude from this.
All right, my name is Noah, part of Team 19, and I'm here to discuss a little bit about the results of our project. In the final report, if you look at the results section, we have two sets of plots. One is the validation accuracy, and the other is the training loss, where we showed that for our data set and for our method, each time we used synthetic data to supplement a small data set, we ended up improving the classification accuracy. And the training loss behaved in essentially exactly the same way that we wanted it to. The main problem that we ran into actually occurred during demo day, where we had an engineer from General Dynamics who works specifically on machine learning, which for us was a great advantage to have him there. He explained to us that commonly in machine learning, you don't want to do all of your training, testing, and validation on the same data set. Otherwise, you face contamination, and there are issues around whether the GAN has seen some of the patterns that you're presenting already. So although our results were good enough for the purposes of our project, we are aware and concerned that there has been some data contamination since we did everything from the same bucket. But these are issues that we'll have to face in future versions, and I'll hand it off to Max for the conclusion.
And thanks to Noah for going over some of that content of our results and demo day experience. I'm Max, and just to kind of wrap up our project, talking about some future work that could be done. Firstly, the quantum aspect of our project got scaled back a lot over the course of these past 2 semesters, and that's another avenue that we'd like to explore a lot more. We got functional code working in Qiskit. We were able to do some simulations on our data set. But ultimately, we need to do a lot of optimization to make any of that aspect work. Additionally, there are some other really cool things that can be done with GANs in terms of like data modification instead of just data replication that could maybe bring us some really interesting results and bring a lot more depth to this study. And also, we'd like to start seeing actual applications to other data sets to try and see if this really is a viable process for more data sets than just the one that we were looking at. So we'd love to give a big thank you to Dr. Kazicki and the TAs for this class, as well as Dr. Spanius for mentoring us through this process. We couldn't have done it without all of your support and keeping us on track. So thank you so much, and this is Team GAN You Dig It signing off.